Okay, in this video, what I would like to cover is going back over and recapping the code from the previous video and fixing a couple of logical errors before we actually move on. So, again, what we have done is we have placed our ball and our paddle on the stage. We got our ball moving around. It's hitting the paddle, it's coming back. If the ball leaves the stage, it randomly gets placed back on the stage. If it hits the wall, ceiling, or any of the sides, it will go through. You see we had one little error down here. If you hit down towards the bottom of the paddle, that it does kind of go through. And also, if we come too close to the edge, sometimes the ball can get stuck right across this edge and just kind of bounce up and down this edge over here. Okay, and what's happening with this is if I go through and place my ball using that math random and it comes out to 0 or -1, it's just going to kind of set here and bounce across the edge out here. So just show you an example of that. We'll start with our ball sitting right here. You can see it's just going to bounce up and down that edge because it's less than 0 and it's coming back. And that's an issue that we don't want to happen when we do that math random. So let's take care of that first. So let's move our ball back out on the stage here. And move my paddle back over. And let's jump into the code. So let's go find our math random that we are doing. And right here, it's if the ball X is greater than the stage width minus the ball width. Okay. And what's happening is if that ball hits that, it's telling it to come back from the right hand side. Well, if the ball X is less than 15, then it's just bouncing back and forth in that area. If the ball leaves the bottom of the stage, we're doing that math floor to round it down to the nearest number, and we're doing a math random. Math random basically just gives us a number between 0 and 1. Okay, so it randomly calculates 0 or 1. So it could be 0, 0.25, 0.5, 0.75, 1, things like that. That math floor is just going to round it down. So if it's 0.25, it's going to become 0. Then we times that by the stage width. Well, the stage width is 800, but 0 times 800 is still 0. So it's going to take our ball, put it out here at 0, and through the code, well, what's happening? We're telling if our ball X is less than 15, times it by a -1. So it's just going to sit there and kind of bounce back and forth over and over again. Okay. So we're going to need to take this and instead of times it by the stage width, I'm going to actually take this and say I want to times that, well, let's say about 750 plus 15. Now we could even come up a little bit higher on this and say 780. So this would give us, let's see, we said 15 up here on the minimum. So let's take this down to 70, not 75, So 770 plus 15, that's going to give us 785. So that's giving us 15 pixels off on the right hand side and 15 pixels off on the left hand side. So again, if our math random comes out to 0, well, 0 times 770 is 0 plus 15. So it's always going to be at least 15 pixels out from the left-hand edge. If it's 1, well, 1 times 770 is 770 plus 15. That's going to give us 785. And again, that's 15 pixels off of the edge. Okay, so we should never get that happening where the ball would actually go through and run just up against the wall or anything like that. So that takes care of that logical error. Okay. Now somebody else has also asked, where did I come up with 0.65? Well, going through and doing your calculations, what we want is if we look at the center of our paddle out here, okay, so what is our paddle width? And mine's about 87, so I could take that out to 87. And we could divide that by 2, and what we're looking for is we're basically looking for about the center of our paddle. So let's color this half about green, and let's go ahead and even get rid of that stroke. And what we're looking for, if the ball hits the black side of the paddle, I want it to bounce towards the right. Okay, if it hits towards that center, I want it to bounce straight up and down. If it hits the left-hand side, I want it to bounce towards the left. So the further left, the further it would be bounced out. And that's going to be based off of our calculations out here. So my ball position is the ball X minus that paddle X. And then our hit percent is taking that ball position, dividing it by the ball width minus, or the paddle width minus the ball width. So this calculation gets done first because it's within the parentheses. Then we do the ball position divided by the paddle, whatever this came out to be, minus 0.65. This 0.65 is based off of just going through and calculating where that ball hit across here. So if it hits off in the black hand side, it's going to be a positive number. If it hits in the green area, it's going to be a negative number. Okay, so it really doesn't matter how big or how small your paddle is. So I can come out here and let's take this and Evie stretch it out a little bit. We should still get that same calculation. So let's hit it in the green side, it's going to go to the left. As long as I hit it towards that center, it's coming closer to 0. Okay, that number is coming closer to 0, so it's that 0.65 is just a magical number going through the calculations that finds the center of that paddle. And again, where's the registration point? Your registration point needs to be on the left-hand side. Okay, if you have your registration point in the center, we could go through and do different calculations, But see how it changed that position. Okay, so it's always going to be bouncing towards the left. Okay, so it's all based off of that position. So I'm just going to go through, make that back to the left-hand side. And let's go ahead and shrink this back down. So we get a nice little paddle out here. And that's another thing you can do is go through, and as you progress through your levels, and we'll get into that maybe in the third video, where when we talk about creating menu systems and other stuff, we'll get into coming back to this game and setting up different levels for this. Okay, so I hope that answered your questions. If not, shoot me an email and let me know. Okay, so let's go through and finish this game out and start bringing in our bricks. So again, I'm going to move my ball down just a little bit so it's not interfering with the bricks to start with. So what do we need to do to get our bricks on the stage? Again, our bricks are sitting out here in the library. They have a linkage name called bricks. So this is going to allow us to communicate with that through ActionScript. So this is kind of like giving it an instance name instead of bringing it on the stage. We can still communicate through the linkage in the library. So coming back out to our code, I'm going to go all the way back up to the top, because we like to define variables up at the top of our coding. That should be one of the first things that you do, is defining your variables. Well, with that, you're probably thinking, well, I just created variables down here in this function. When you create variables within a function, they are only accessible to that function. So I cannot call or look at ball position within my game loop, because it would not be defined. So if we create variables within a function, they're only accessible to that function. Okay? So I'm just creating a variable. Anything up at the top is a global variable that we could use throughout our entire game. So it doesn't matter what menu system we are in, we can still look at these variables. Hope that makes sense. So, need to create some variables. My first variable, I'm going to call brick count. It's just going to be a number, and I'm going to make it equal to 0 to start with. This is going to let us know how many bricks have we hit with the ball. We're going to add to that count as we go. Next variable, total bricks. How many bricks do I need for my game? Well, that's going to depend on how big your bricks are when you make them, and how many do you want placed on the stage. So for my game, I need 27 bricks. I'm going to have 3 rows come out of 9 bricks in each row. So again, looking at my brick, if I bring it out, let's look at the width of my brick. My brick is basically 68.4. I could even take that up to about 70. Okay. Registration point on my brick is in the center. Okay, so we're looking at the entire brick, not just that registration point. Okay, and I'm going to have about 9 of these out here. So you could go through and just kind of duplicate these to see how many you can fit across your stage. Okay, So just taking these, I could probably fit 9 across my stage. If I go through and let's distribute those evenly, you can see I could fit 9 across the stage and calculate the spacing in between each one. So let's bring these just a little closer together. Let's redistribute those if we can to make it look a little better. Okay. I'm not going to worry about that. We're going to do that through code anyway. But I can have 9 going across my stage. Okay. So how do we bring these out? Well, I still need a couple more variables. I need a row. That's going to be a number equal to 0 because we're going to start at row 0. I'm going to create another variable for the columns. So I'm going to call that call. That's going to be a number equal to 0. So we can go through and kind of visualize what we are looking for. We're looking at the rows. How many rows are we going across? And how many columns do we have for each row? So starting at 0 for the rows, coming down, and starting at 0 on the columns. That's why our two numbers out here are going to start at 0, 0. Okay. Now we need to create a variable, and with this variable we need to loop through it because we're bringing out multiple bricks. So to bring out multiple bricks, we're going to use a for loop. So basically it's going to go through and loop through this code as many times as we have our total brick numbers. So we're going to create for, F-O-R, and within parentheses we're going to define a variable. When you're dealing with for loops and while loops, might get into while loops later, just another way of looping through. I like using for loops. Our first variable in here is going to basically tell us what number is we are going to add to the name. So each name is going to be unique as well. So I'm going to create just a variable. I'm going to call that B. I just like using single letters. Most of the time in for loops, when you're programming, you'll see a lot of programmers just use the letter L just for a single number or single letter out there. I like using the first letter of what I'm using. So since I'm bringing out bricks, I like using B. Okay, this is going to be a number. And that N needs to be capitalized. It's going to equal 0. Semicolon. Then we're creating a condition within this for loop. My condition is going to be B is less than my total bricks. Well, I have 27 total bricks, so it should loop through this 27 times. So this is just like writing an if condition. Okay. Semicolon B plus plus. B plus plus adds 1, so that plus plus will add 1 to B every time it goes through this loop. Parentheses. Open curly bracket, closing curly bracket. So basically what this is doing right here in this for loop, we're generating our variable. We're checking the condition of that variable to see if it's less than the total bricks. And if it is, we're going to run through this code down here. after we run through the code at the end, it's going to add 1 to that. Again, plus plus will add 1. If we use minus minus, we would subtract 1. Okay. So in our code, I'm going to create another variable. I'm going to call this new brick. And this is going to be a movie clip. Since we are dealing with movie clips in the library, I'm bringing out a new movie clip. And it is going to equal a new brick. Okay, now when we are creating this new brick, we need to have it the exact same name as we have in the linkage, so we know what we're talking to. I called this bricks, so I need to say new bricks. Open and closing parentheses, and then a semicolon to end that line. And then I'm going to say this square bracket. Okay, we're not using the curly braces. We're using that square bracket. And when we use square brackets, we know we're always talking about an array. Well, what is an array? Array is basically just a list of different names. So you have one list, you have multiple names under it. You could also think about an array like a music CD. You got one CD, but you have multiple songs on that CD. Okay, I hope that makes sense. It's one object with multiple things within it. Okay, now with this, we are giving this a name. So double quote, and I'm going to call this brick, plus, well, let's end that double quote, plus B in the closing square brackets. So now what we are saying with this is that this name, brick plus B, whatever we bring out is going to equal that name, brick plus B. So the first time through, brick is going to equal 0. Second time through, brick is going to equal 1. So we'll say brick 0, brick 1, brick 2, until we get all 27 out. The final one would be brick 26, because we're always starting at 0. Okay, we're always starting at 0 up here. So this is going to equal my new brick. Okay, I'm going to copy this here because I'm going to use it multiple times. I want to make sure that I use that same name. So my brick.x, because now it's a movie clip out there, I can give it properties, is going to equal 78 times the row plus 85. We'll go over these numbers here in a little bit. Brick Y value is going to equal 20 times the column plus 50. Okay, well, we're defining these, but we still don't have that brick on stage yet. So we need to do an add child. Add child, we're just going to say this brick B. What add child does, it will actually take it out of the stage and set it at its registration point to 0, 0. Well, I've already defined where I want my first brick to be. Okay, so with that first brick, we're telling it exactly where to place it on the stage based on the width, the height, what row and column, and what position to place it out there. Okay, so I want it 85 pixels from the right edge, 50 pixels down from the top edge. Okay, now after this, I need to tell my row to increase, so plus plus, add 1 to the row, and then if my row is greater than 8, I want my row to equal 0, and I want to increase the column. And I just used 1L, so plus plus. Okay, so let's check our syntax. Checking syntax is as easy as just clicking up here. You got a blue little check mark. No syntax errors. So let's test this out and see what we get. So we got our 9 rows. So if we're coming across 4, 5, 6, 7, 8, 9, and where are they positioned? Okay, so now if I came through and changed these numbers, again, this is kind of looking at the width of our brick. So if we come in here and take a look at this again, okay, so it's kind of looking at the width and the height and adding just a little bit to that to give it some space as well. Okay, and we're placing it in the row 0, because 0 and 0 plus 85. So if I take this and say, let's say 65, you can see everything's shifted over to the left hand side, because on the X we're starting at 65 out there. Okay, because if I took this down to 5, whoops, it would start right at that edge, and it's looking at the registration point. Remember, it's always looking at that registration point. So now we only see about half of that. Okay, so that's where this is coming in. This is on the Y value. So if I take this down to 5, it's going to be closer to the top. So we're only coming down 5 pixels off of each one. So, and this is the spacing in between. So if I took this down, you can see they're going to be a lot closer together. Again, that's their spacing. These numbers are the spacing in between each position. So if I took that up to 50, they're going to be spread wide across. If I took this up to 100, they're going to be spaced out further, and you wouldn't see all 9 on here. So if I actually grab that, you can see some are setting off the stage. So our first number here is spacing. So that's where we added to that to get some spacing in between each one, and the spacing on the Y values. Okay. So I got all 9. Now if you wanted more bricks out there, well, let's take this up to the next value. So 36. Now I got 4 rows. Maybe I only want 2 rows. We can take that down to 18. Okay. If you don't have it equally divided, let's say I had 16, you'd see we'd miss a couple of bricks out at the end. So how many do you want going across? How many do you want coming down? And it's all based off of how many bricks can you fit across your stage, and how many bricks do you want up and down in each row? How many columns? How many rows? Okay. So next we need our ball to actually start hitting those bricks. So coming back down into our game loop, we're going to start calculating how we can hit each one of those balls. So coming after my hit test, I'm just going to create another function, and I'm going to call this collision detection. Go ahead and copy this name. Let's come down after our curly brace for our game loop, but before the function call ball angle or calculate the ball angle. Let's create this function in here. Semicolon, void, because they're not going to return anything. Okay. Now to calculate these on the collision detection, again, we have multiple bricks sitting out here. So we brought those out using a for loop. Okay, we brought those out using that for loop. So we need to go through and use a for loop to actually calculate which ball we are actually hitting. So again, we're going to create a variable. I'm going to call this one CD for collision detection. Okay, and again, it's going to be a number. It's going to equal 0. Semicolon. BC is less than the total bricks. BC plus plus. Now in here, I'm going to create my condition if the ball dot hit test object. And what do we want to hit test? Well, I want it to hit this square bracket, double quote, brick, double quote, plus BC. So, or CD, I'm sorry. And this one here should actually be CD, as we're using that collision detection. And let's close that. And double parentheses at the end, because we got our first parenthesis for the hit test, the second is for the if condition. Open and closing curly brackets. Well, if my ball hits brick 0, 1 through 26, what do we want to happen? Well, I want my speed y 2 times equal a -1. Send it back to where it came from. I'm going to add to my score. So score plus equal, let's say about 10. Well, we haven't created that variable score yet, so we're going to have to do that, or we're going to start getting some errors. And then I'm going to tell this brick plus CD dot X to equal 999. I'm just moving it off the stage for now. Okay, so I'm just going to move it off the stage, get it out of my way. I'm going to tell my brick count to add 1. And then I'm going to update my score. So my score txt, that's its instance name. It's a text field. So dot text equals string, and within double quotes, score plus that score field. Now when we're dealing with text fields, it can only hold string values. Since score is actually going to be a number, we're going to need to specify that we're going to convert that number into a string. Score here is just creating a text value. Okay, so it's creating a string because we put it in double quotes. The plus is going to concatenate score to the end. So I'm actually going to add a semicolon space. So it's going to see that space, everything won't be bunched up. So it's going to say score semicolon space and whatever the score value is. within that. So now I need to go up and let's define score up at the top. So coming back up to the top, just under the hide mouse, I'm going to create the variable score. And that's just going to be a number, and it's going to equal 0 to start with. Okay. So let's check our syntax, see what we got. No errors. Let's go ahead and test this. Make sure everything's working. We hit that. It's updating. Our score field down below is updating. Okay. See if we can get in behind these guys here just a little bit. And get them bouncing up towards that top area. And hopefully that should, oh, got a couple there. You can see our score is updating every time we go through. It reflects our ball back down. Okay, if we hit multiples, it just send that ball back and forth anyway. Let's see, now with the calculating that ball angle, we're not just going through and making it go left and right every time we hit the paddle. We can actually control where this ball gets tossed. Okay, let's see if we can get back over here, take care of those two. Just kind of finish these guys out. By playing this all the way through, and we still have some more work to do off of this. Okay, we're getting pretty close. This video is running just a little bit longer than I'd like. Okay, one more shot, and that should take care of it. And let's see, calculate that. There we go. Well, we hit all the balls or all the bricks. All the bricks are gone, but our game is still playing. Okay. So what we need to do is actually go through and end the game as well. Okay. So after we have gone through, hit all the bricks, we got our collision detection working, we need to kind of end the game. So to end the game, we're going to check if our lives is equal to 0. We haven't defined lives yet, so I have to do that. Or, with or, we're going to use double pipelines. Okay, that's holding the shift key down, and just above the enter key you got the slash, and then what looks like two slashes. That's our or statement. That represents or inside of Flash. If we wanted to represent and, we'd have two ampersands. So if my lives is equal to 0, or my total bricks, or let's say our brick count, equals double equal sign to check the equality. Single equal sign assigns a value. Two equal signs checks for the equality between those variables. My total bricks. So if it's my lives is 0 or my brick counts equal each other, I want to tell my stage to remove that event listener. So I'm just going to come up here to the top. Here's my event listener. Let's just copy that. Let's come back down, paste that in here. And instead of add, I'm just going to change that to remove. So it removes that event listener, and you usually want to do this right at the end of that game loop. Okay, it can be done in other spots, but it's best if we do it right at the end of the game loop. I'm going to tell my paddle to stop drag so it doesn't move anymore. I want to show the mouse, so mouse show. I want to go through and kind of run a cleanup. Okay, what are we going to do to run a cleanup? Well, cleanup is just kind of cleaning up the stage. Okay, making sure everything is taken care of. So if we do go over into another level, that a lot of stuff won't be sitting on the stage again. So I'm going to just run a function called cleanup. Okay, and this is where you would also want to go to your next scene. And I'm just commenting that out. And basically all I'm going to do here is trace. Now I'm going to trace game over. Now what a trace statement does, it will put it out to that output field. Okay, so this, once it hits that, the output field would pop up and it should say game over. Okay, but if you have your next scene set up, you wouldn't want to trace anything out. Okay, so a couple of things. I need to create my lives variable, so I'm going to copy that. Let's go back up to the top, just underscore. Let's create that variable. Lives, it's going to be a number. Okay, and how many lives do you want to start with? Well, I'm going to start with about 3 lives. Well, how do we subtract that? Well, if my ball leaves the bottom of the stage, so if my ball.y is greater than the stage height minus the ball height, okay, this is where I mathematically calculate putting it back on the stage and set its value. But also, I want my live to minus minus. Minus minus goes subtract 1 away from it. So every time that ball, you miss the ball and it leaves the stage, you're going to lose a life. Okay. So, and let's go and define our cleanup. So let's copy this. In my cleanup, I like that to be my last function. So cleanup void, because again we're not going to return anything, open and closing curly brackets. Now in my cleanup, basically all I really need to do in here is go through and remove the bricks that I've set off the stage, because if we go to a new level, we're going to bring in new bricks, maybe in a different pattern or something like that. So in here, we're just going to create a quick for loop. We got that variable cu for cleanup. That's going to be a number, and that's going to equal 0, semicolon, cu is less than the total bricks, semicolon, cu plus plus. Now, to remove these, all we're going to say is remove child. And what child do we want to remove? We're going to remove this, square bracket, brick, plus cu. Okay, now so we can see this a little better, instead of moving this off to 9999, I'm going to move this off to, let's say about 600 on the X. And let's go ahead and just copy this just so we can see this cleanup working. And let's take about 400 on the Y value. Okay, so every time we hit a brick, and let's see, semicolon before a colon. And let's see, we got compile error line 9. So I probably put a semicolon up here instead of a colon. Yep. And what was the other one? 117. Line 117. So number, semicolon. Oh, need a parenthesis. Okay, so hopefully we hit this, it just pop up. Oh, we got to drop that down lower so we don't keep hitting it. And let's see, let's drop that down to about, let's see, what number do we have down here that's setting below? So about 550. Let's move that down to about 550. Okay, let's go through in these just real quick. And I'm actually going to take our brick number down to about 3 so we don't have a lot of bricks to shoot at. Just 2. We can take care of these 2 bricks real quick. There's our first one sitting down there. There's our second one. Clean up. They disappear. Everything stops moving. Our mouse comes back into play. We have game over. Now, we also need to test. If we miss it, we get 3 lives. But our lives aren't updating. But now game is over. So we need to make sure that we update our lives as well. Okay, so wherever we go through, let's go ahead and update our lives. So inside here, we need to update the lives so they actually show in that same area. So we're going to say our lives txt.text. Again, lives txt is the instance name I gave it. That's going to equal string lives colon space quote plus lives. So you can see our lives down at the bottom right are updating. We got 1 left, 0, game's over. All right. If you guys have any questions about the scripting, definitely let me know. And if I need to create an update to this, we can do that. Otherwise, I hope you guys enjoyed this. There will be new ones coming soon, and we'll start talking about those once we get there. Thanks for watching.